So hello, rubyday. As she said, he's Anatoly, I'm Cristian, we work at Zendesk. Zendesk is a pretty big company that was founded and still to today uses Rails. And we're going to talk about the history of the last 15 years of it. I think it's actually very nice that we are talking here in Verona, because I see a certain relationship of the city, or of the most famous story about the city, with the Rails community. You know, again, this talk is going to be about the history of Rails and the history of Rails community. And you will be thinking, what are you talking about? How is this related? Okay, spoiler alert, so if someone doesn't know what Romeo and Juliet is about, you can leave the room now. I mean, you're 400 years old, 400 years late. But well, let's say Romeo and Juliet is the story of these two families, the Montescos and the Capuletos, that they have fought for generations, and then two teenagers of each family fall in love, and this kind of triggers a huge drama, like death, suicide, poisoning. It's terrible, no? It's maybe the biggest drama in history. So how is this crazy drama related to the Ruby community? I mean, think again about that. How is drama related to the Ruby community? I mean, come on, I did a compilation of dramas. Apparently there was a website called rubydrama.com that put all of them, and you see, only you can stop the Ruby drama. Millions of unicorns die each year due to unnecessary drama in the Ruby community. I mean, don't get me wrong, I love drama. Huge entertainment value. Like, for a while I tried to be a Scala developer, that was terrible times. And I went to conference in Scala, and you see, like, the typical speaker in those conferences looks like this, you know? It seems like AI generated. While our typical speakers in a Ruby conference look like that. I mean, all respect to Tender Love, but I mean, others, some of us know how to dress to impress, but he's a bit like this. Okay, so introducing the talk, there is a reason why I wanted to talk about the passage of time. It's a bit of a special moment in my life. I am originally from Barcelona, but I moved abroad for 10 years, first to Denmark, then to the US, and I moved back recently. I also made my 10th anniversary working for Zendesk. And finally, this is kind of a nerd thing, but I started watching this TV show called Frieren. Does anybody know what is this? Okay, so basically Frieren is this typical anime in a world of elves, warriors, wizards. But the main idea that they use there is the passage of time, because Frieren is an immortal being, and they play a lot with the idea that this person has seen it all before. Moreover, in my opinion, in Frieren they use magic as something that can be read as technology, or at least you can see the progress of magic that follows similar patterns to the progress of technology. This is actually not something super new. My favorite fantasy novel, A Wizard of Sea by Ursula Le Guin, that's incredible. Yeah. I always read it in the same way. So in the magic in this world works the following way. If you know the true name of things, you have powers over that thing. I always think that it's like object-oriented programming. If you create a perfect abstraction that is impossible, then you gain power over those objects. We all work with terrible abstractions, and we know the difference. No? I mean, again, all these ideas are not mine. Arthur C. Clarke has a very famous quote about the relationship between magic and technology. Any sufficiently advanced technology is indistinguishable from magic. But well, going back to time and Frieren, you need to think that in this world, it's very structured, like the show is very structured around flashbacks. So you see her when magic was something very, very rare. Then you see her 100 years before, where there was a spell that was considered incredible. And then you see her in the present, that same spell is now the base of everything. It's something similar to that happens in technology, that something amazing 10 years ago, now it's completely normal. Moreover, I think for Anatoly and me, it was natural for us to identify with this character. Like, Frieren is an elf that has lived over 1,000 years old. That makes her the possessor of forbidden, forgotten magical knowledge. And I would say that we are equally mythical. I mean, we are engineers that have worked in the same company without changing for 10 years. That makes us the possessors of forgotten, forbidden magical knowledge. And we are here to share it. We'll start the discussion talking about the monolith, both how the monolith evolved at Zendesk, because Zendesk was originally a pure Rails monolith created in 2007, but also about the concept of monolith. I've seen a lot of things changes, like I started working with Ruby late 2000s, early 2010s. I was way younger then, but the 2010s were weird times. We liked all kind of strange stuff, and then in the late 2010s, the idea of monolith became not cool anymore. I remember going to an interview, and when I said yes, I think monolith makes sense in the context of startup, they look at me like, go away, Now, kind of the concept of monolith is trendy again, or at least not as bad as it used to be. For me, this is not a surprise. I personally believe that a lot of debates that we have in tech, they behave like pendulums. Something that was completely mainstream 10 years ago, then becomes terrible, and then goes back to a more balanced position. Understand, here I don't mean that you can say whatever and nothing matters. There are debates that suggest a very dangerous pendulum. For example, 6, 7, 8 years ago, I think, relational databases they were at this trend like NoSQL, which makes sense in certain contexts, but there was a lot of people saying that we shouldn't use relational databases at all, and SQL was kind of dead or in the way out. Well, that wasn't the case eventually. And if you think that this was a spicy take, I have one way more spicy. I actually think that the boom of microservices in the last 10 years is a zero interest rate phenomena. And by this I mean tech companies had so much money that they went in a lot of cases for preemptive optimization. I am not the only one that thinks this. Actually, 1 or 2 months after I did this presentation the first time, DHH put this tweet, which I kind of agree. Maybe I wouldn't written it that way, but it's DHH. But I mean, I've seen this because I really remember a friend of mine that was talking to me about his new startup he just joined, and he was describing to me. He was describing to me this incredibly complex architecture I couldn't understand, but I was thinking, well, I'm happy for you because this seems like very popular. Said, no, we have 10 customers. It was like, okay, man, I don't know. Moreover, now that unfortunately, there is less money in the market, when companies need to reduce amount of engineers, having to support 2,000 services is going to be very, 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 very hard. Like this from a newsletter I found where some company complained about this. Said this, I do believe that microservices make sense in a lot of use cases. I have a very different opinion from, let's say, Elon Musk, that's called microservices bloatware. I mean, I find this hilarious, but I wouldn't go that far. My opinion is more similar to Jason Warner, the CTO of GitHub. He believes that there is like a spectrum. A lot of times when you are a startup or you create an application that needs to try to find market fit, let's call it, you need to start with something that you can evolve very fast and then slowly break it down into different services. Actually, with this, we go back to Zendesk. Because internally at Zendesk, we had a lot of debates about that, but somehow what we end up doing is kind of like that. We broke some parts of the monolith into services, but I still think that if you are someone onboarding into Zendesk in 2024, you will feel that it's similar to a monolith. It's pretty monolithy. Said this, we had different visions doing all these 15 years. Originally, our first CTO, Morten, had this idea of, I'm going to create a monolith in Rails, but then I'm going to extract part of the logic. So it's perfectly modular. And then in the future, we will be able to spin new Rails applications that have a lot in common. If you check the gem file of the monolith at Zendesk, you have a lot of gems like that. And actually, we don't create applications like this anymore, but we have a few applications that do that. They share code through gems. Then we move to what I call the service era. This came a lot because we acquire companies, and we wanted them to share data across the ecosystem. For example, we acquired a chat company. We wanted to share accounts. It didn't make sense for us that the chat product calls the support product to ask about accounts. So we created an account service. And finally, these days, we are doing more of an event-driven architecture. So if something happens in the monolith, it generates a Kafka message that is consumed by other services, and this triggers multiple actions. But going back to the monolith, our way to grow it now is experimenting more with modularization. We are playing a bit around with Packwork. That is a gem created by Shopify that helps in this regard. And that would be it, but I wanted to comment a little bit on the front end. What happened in the last 15 years in the front end side of creating applications? Well, again, I joined the tech community in 2010, which was strange times. And at that time, it's when it started one of the most violent conflicts in human history, which I call the Great JavaScript Wars. I mean, if you remember, if you were active in those times and you entered in Hacker News, chances that every week there was a new JavaScript framework. This still happens today, but the difference is that then all of them were somehow getting traction. It was very hard to follow. Like at Zendesk, we used a lot these three, Backbone, Ember, and React. And I'm sure that somewhere we use also Angular and other stuff, but these were very used. I mean, there is something about JavaScript engineers that they seem to love creating new frameworks. We have something called Card.js. Card.js, you don't know it for sure, because the reality is that someone called Card, nobody at Zendesk remembers his last name anymore, created his own framework. And it is undocumented, of course, and we are building on top of Card.js. It's something fascinating. But still, it seems that in the last years, we kind of agreed to go on the React way. Yeah, there are other frameworks, but seems like React is kind of the king of the hill at the moment. And I like React. I use React at work. I use specifically React Native a lot for my own applications. But sometimes I feel that this victory of React is just because people got too tired. You know, it was just hard to follow with the JavaScript ecosystem. The next part, I would like to talk about deployment. We don't have much time, and this is like a very long story. But let's say that when Zendesk was started, we went using virtual private servers like EngineYard, Rackspace, and with each of them, we kind of went over the limits that what they were expecting. It actually, at that point, it just made sense to go for our own metal. I think at that point, we were kind of a little bit pioneering this, like we didn't have the right tools. So eventually we moved to AWS, and we've been in AWS since then. If you want to know more about this, we have a series of articles about that with an interview with the first CTO of Zendesk that can illuminate that better than me. The next part, yes, I know that this is a Ruby conference, but I wanted to talk about how do you adopt new technologies in a big company. Again, we are a Ruby shop, more or less, but Ruby is very important for us. But then, of course, you start thinking, how do you adapt new technologies into the stack? Well, when you're a startup, it's very easy. A lot of times, you can be even one engineer that decides to, hey, let's use Card.js, or let's use something, and you talk with your manager, and then that's it. But the problem is that when you're a company that has around 1,000 engineers, that doesn't scale. That becomes foolish. It's the cognitive load of having to support hundreds of languages is just too much. So we created something called the tech menu. So the idea of the tech menu is that, hey, you want to add, I don't know, Elixir to the systems that we use at Zendesk, to the programming languages. Great. Do a proposal. We have an architecture team that decides in which path we should go, and if it's accepted, that's it. You can create applications on Elixir. It's funny that I use Elixir as an example, because I think French have a word for that, like cause célèbre, like famous case, was about which language should we use for creating services. I was in Team Elixir, that's why it came to my mind, and I kind of lost. So we don't build services using Elixir at Zendesk. We use two languages, Java and Scala. One thing that was very fascinating is that both were accepted because two very significant parts of the company opposed a bit. They both defended them. And for a while, it was completely accepted and equally defended to use Scala and Java. I would tell you that as 2024, we kind of prefer to create services in Java. And interestingly, the reason is that it was very hard for us to hire people in Scala, to train people in Scala. It just became very hard to maintain our Scala systems. So we just prefer Java these days. But actually, the main way that we adopt new technologies at Zendesk is via acquisitions. You can say whatever, but if you can say whatever about Python, for example, But if the CEO wants a company, and this company is using Python, Python enters the stack. For us, acquisitions are important. Around half of our products came via acquisitions. And I will just exemplify this with our first acquisition. That was a company in Singapore called Zopim. Zopim is a chat company, and the product nowadays is called Zendesk Chat. As I was putting example, they were using Python, and Python is a Zendesk language. But from a software engineering perspective, I think the most interesting part is what I call domain fusion. We are a customer support company. We have the idea of ticket, of user, of ticket. This is the main center. A chat company has the concept of chat, I guess, conversation, whatever. It's completely different domains. And then suddenly, all the chats in this company need to become tickets somehow, because they are now not a neutral chat company. They are a part of a customer support product. It's a bit like in Star Trek. I think they're called as orcs. You know, you need to absorb and make one out of two. So again, what is a ticket? What is a chat? Now we have a product called Things, Zendesk Voice, that phone calls are also part of this customer support flow. I mean, yeah, this is a product problem because it's very important from a product perspective that your customers feel like they have a unified experience, but it obviously has deep consequences on the technical side. Now something that was modeled for years as a conversation needs to be part of a ticket. Eventually, what I felt is that what we needed is shared features, common features into very different objects, a bit like interfaces. And the final solution is that everything eventually becomes a ticket for us. So any object created by an application calls the monolith, originally via an API call, now through Kafka messages, and generates the basic slate for everything that is the ticket here. Okay, and after this kind of product conversation, Anatoly here will tell you realities about performance.
Test. Can you hear me? So I had very boring 30 slides, and then I talked to Bozhidar, and now my slides are not boring anymore. I hope. All right. This is the photo I have taken. I took probably maybe 2 years ago. Has anybody been to Dublin? Know about Dublin weather? Okay, quite a few people. So we believe that we don't have any summer, and if you want to have summer, you come to Italy, right? Well, this is what I was thinking, and then I checked Wikipedia, and this is what I found. How many sun hours we have per year in Verona versus Dublin. I was shocked. So Dublin is supposed to have 0 hours. No, it's not 0. And why am I showing this slide is the system. We think about a large system. It's very similar to weather. We think it's something one, but it's something else. It's completely something else. And now attention, Bozhidar has to smile, and everybody has to say. I love it. Okay. So this is the photo I took 7 years ago in Dublin, with 3 days of snow, no traffic, no buses, no flights, nothing. So the system we work with at Zendesk is similar. It's unpredictable, very unpredictable. This is the photo from San Francisco where we have our headquarters. It's supposed to be sunny, but it's not. So again, it's a challenging weather. And sometimes the system makes its own decision for you. So you don't ask. And the system behaves one way, but you can't explain. And next slide I stole from Cristian. I think that was my only funny slide. And I made it even more funnier. All happy systems are alike. Each unhappy system is unhappy in its own way. Yeah. I have to take a 50 seconds pause, but I don't have too much time for that. Yeah, it's like, yeah, okay. I'll skip it because I don't have time. Zendesk transitioned from AWS, from data center to the cloud in 2016, I believe, 17.
Yeah, that's when we started the process. I think we ended in 2018, I think.
2018 when we finished. And if you ask, what was the biggest challenge with Zendesk? it was the database. So database performance was the reason why did it take longer and why we had many problems than we expected. And does anybody know the law? The law. So if your system is stateless, you have no data. It scales forever. It scales like, well, but does anybody have no data in your system? No, no hands. One hand? No hand. So as soon as you have small data set, performance degrades. But as soon as you have large data set like we have at Zendesk, you hit the moment of contention. And now I should have Božodar's slide. I don't know why I don't have it here. I think I have it a couple slides later. Yes. Happy large systems have one thing in common. And this is the happy databases. Happy performant databases. There's no large system which is safe, reliable, fast, with an unperformant database. And performant databases have one thing in common. And you have to pick 2 out of 3, okay? You either have consistent runtime and complex queries but small data set. You have complex queries, large data set, but forget about performance. That's it, okay. Thank you, Božodar. And this is exactly what happened to Zendesk. This is our past. Data set was small. Query runtime was relatively consistent, and we could do anything we wanted. Anything. Absolutely anything. The future, actually, present is a little bit different. Query runtime took the back seat because the data set took over. The future is different. The future is no complex queries whatsoever. Large data set will dominate, and performance of the database and API endpoints will be consistent. Back to Cristian.
Yeah. And after this, that actually is what you should keep in mind, because what I say is mainly stories. We'll talk a little bit about testing and reliability, like how we use tests at Zendesk to keep our hundreds of thousands of customers happy. But before that, I would like to comment a little bit on a typical debate in the Ruby community, that is tests versus types. So in 2010, like the proposal of Ruby was that you don't need types if you have tests, and you need tests anyway, so you don't need types. With the time, in the late 2010s, or maybe more recently, I think in the community there's been a bit debate about that. I think Ruby 3 supports type checking natively. We also have Sorbet, that is the gem that adds type checking. So there is a debate here. I will tell you at Zendesk, in this debate, we are extremely on the side of tests. And for tests for us are incredibly important because we have a lot of code, around 1.6 million lines of code. And we have an absurd amount of tests. How many tests do you think we have? Like unit tests. I'm not counting feature tests or iteration ones. Say numbers. Eh? No. How many tests? Unit tests. Oh. Yeah. Okay. So, well, close. 55,786 tests. We do have, actually, it's more than that, because some tests we use metaprogramming and a loop, and they run in different ways. Then you will be thinking, how the hell do you manage this? Oops. The reason for this, we manage this thanks to one person, that is our personal Cerberus, that is guarding the main branch of the monolith. It's called Ryan Davis. This is his real avatar in Slack. Let me merge or I will cry. Like, literally a few months ago, we were onboarding a new junior engineer, and I was waiting for him to complete a feature. Say, hey, Cristian, I'm sorry, I couldn't merge. There is this guy that is telling me that my tests are wrong and I cannot merge this. And I was like, oh, you met Ryan. Some of this, you may know Ryan because he's also the creator and maintainer of Minitest. And actually, this brings me to the second comment that most junior engineers make at Zendesk. Why Minitest? And by why Minitest, they mean, why not RSpec, which is, I think, the most popular test framework in the Ruby community? Well, there's a good reason. We do have a lot of tests, and to make it even worse, we run all the test suite twice every time there is a push. Later, we'll explain why. So this means that every time that someone does git push to GitHub, we're running 111,572 tests. So the advantage of Minitest against RSpec is that it's smaller, less magic, and it's way faster. I talked with Ryan, and he told me that other big companies using Rails, like Shopify, also prefer Minitest for this reason. In fact, when we try to modify Minitest, we try to make it less magic, less faster. We care about that. Still, despite that, we have pain points in our testing pipeline. They are flaky tests. A flaky test for us can be terrible for productivity. Because again, imagine this is like a real snapshot from our PRs. There is like 120, I know how it's called, checks being run. Each check is around 2,000 tests. So if one test is flaky, you need to rerun it. This means that you need to rerun 2,000 tests. They can take around 20 minutes. That's pretty painful. Moreover, now we're in a much better world because I don't know if you remember, but until 3 years ago, you couldn't rerun one check in GitHub Actions. You need to rerun all of them. So this means if you have one flaky test, this means rerun over 100,000 tests. That was very painful. And so that was a very happy day when GitHub released that. But say this, I would say that the true secret for reliability for us is ownership. Everything needs to have an owner. Why? Well, we have a lot of code, and we have a lot of committers. I checked the monolith, and there's been 2,459 different accounts of it that push code into main. And okay, you may be thinking, well, this application has been around for 17 years, of course. Most probably lately, there's way less people. Well, the last year, 570 different people. So a lot of people pushing code. And if you don't have pretty clear processes, you're going to end up in a fight. It's going to be very hard to know who did what, who had responsibility of fixing certain things. So we have a rule that all files are owned by at least one team. Like this, it makes it way easier if something breaks to find who needs to fix it or who needs to work on that. It's super important. But still, of course, I couldn't have a talk about history of Rails without explaining what happens when you upgrade Rails. Because again, Zendesk is kind of ancient. Was started in Rails 1. Actually, there is a story about that. The original founder of Zendesk, Mikhaylov, used to work with DHH before DHH created Rails, so they know each other. We used tests for upgrading Rails. How do we do that? Well, remember I told you that we ran all the tests twice? So what we do is, of course, we run all the tests with the current versions of Rails, and then we run them again with the version that we want to move next. The idea for that is that if it's red, that's optional, that's fine. But once a test becomes green, we do not accept that this test goes back to red again. Like this, because imagine, you are trying to upgrade the version, you're fixing problems, but someone introduces something new that isn't compatible, you will never end. Like this, we can guarantee that we will have retroregressions, I think they're called. Still, we have had historically pain points when upgrading Rails, and I think this is something that can be pretty interesting for you because, again, I've been around since 2010. At the time, there was something that was incredibly popular in this community that was not popular at all in other programming communities. And it's one reason why I started doing Ruby. And the next slide hurts my heart because I love the book, but this is the reason, metaprogramming. I literally fell in love, I literally have the book signed by Paulo Perrotta, he's my idol, but oh my God, metaprogramming is such a pain when you go try to upgrade. We had, until Rails 5, we had our code full of monkey pouches, some ghost methods. We had gems that we were using in the main branch, but then we had modified versions of the gem for us. It was terrible. Eventually, it doesn't scale. It becomes just the cognitive load is just too hard. Still, we moved, for a lot of years, we were keeping this up until it got to a point of upgrading to Rails 5. Basically, when we tried to upgrade Rails 5, all tests broke. It was nothing worked. So at that point, we decided to go hard mode and remove all the metaprogramming or as much metaprogramming as possible from our app. Moving from Rails 4 to 5 took 2.5 years, and with people dedicated to it. This is like the last year of progression, of amount of errors, failures, how much it went. And you'll be thinking, what were the specific issues that were crazier? Well, we had our own branch. Basically, the most important things were issues that were distributed across the whole code base. For example, stronger parameters. We were using a fork of stronger parameters. And when we arrived at 5, we decided, this doesn't make sense. We don't want to be maintaining stronger parameters forever, our own version. Let's go back to Rails, the Rails way. This was hard. Still, the most famous issue that we had, and it's something that the community got a bit angry at the time, was dirty attributes. That was actually a thing with Rails 5.2. I don't know if you remember this, but the idea is that, so you have an object in Rails 5.1, you change an attribute and you save it, you do user.object.change, it will return true. In Rails 5.2, it was decided that if the change has been committed, the method change, should return false. We're using a lot of logic based on that. And actually, this was not even like, oh, there's an exception now. It's just that it just returns different value. So this, actually, I was talking with Ryan about this, and he is very strong believer that this should have been a major change and should have been in Rails 6. But it was really, really problematic for us. I mean, this thing alone, I had 6 months to the upgrade. And there is a reason for this. This seems crazy, but imagine that you have an application that is being used by 500 engineers every year. That means around at least 100 teams. You need to communicate with 100 teams, tell, please, could you check that those hooks that are broken, fix them? Everybody has their own roadmaps, there is communication issues. You discover that some endpoints don't have an owner. It's really hard to change. The good news is that since then, it has been way easier, and now, more or less, we keep up with the latest upgrades. Still, maybe the lesson I want you to take is what I call the first mover disadvantage. So if you have, there is something that you want to do and nobody else has done it before, there's going to be a price that you're going to have to pay. One example, sharding. We've been using sharding for a long time, since probably Rails 2, and we have our own gem, our own stuff. Recently no, maybe 5 years ago, that was probably before the pandemic, Rails 6 came with sharding, like out of the box. We're still using our own version of sharding, and we want to move to the main branch of Rails of sharding. So my advice after all this would be to, well, join the party. Essentially, don't develop something by yourself, close in your little room or your little private repo. If you find a problem and you think there is a solution, like mainstream, create an issue, talk with people. Maybe you will find that someone is already working that solution and you can join. Or maybe it's something new and you can become a Rails contributor. What I don't recommend is just maintain your private solution for years, because eventually there's going to be another solution that will be public and will be maintained by a lot of people. And eventually that solution is going to be better than yours, and you're going to have to adopt it. Okay, we are getting to the end. This presentation is a bit of a sequel of the previous one that we did. Last year we were talking about performance, scaling an application, but from a performance perspective. The things that after talking with people, I realized that not being to scale an engineering organization, not being to scale processes, is way more problematic. I mean, in the end, performance problems are kind of easy to detect. So if an application is too slow or doesn't respond, well, you have a huge problem. But the slowness of an application is kind of obvious up to a certain point. With processes, organizations is completely different point. Like even how a good organization looks is kind of an object of debate. It's not very clear to me. So then I started to think, okay, how do I imagine this ideal organization? How do I imagine this ideal process? At this point, I started to think about the past and all the things that I've seen at Zendesk or in different companies, and seeing, well, maybe I can take things out of what I've learned. And this, when you've been around in a company or in a place, you feel a bit like Gandalf, like, oh, I have this secret knowledge that I can share with people. I have power, no? But then you start to realize, and I saw this a lot, that the past can make you also like Saruman, Someone corrupted, because the past can become this little thing that talks to you, say, this is not the way to go. I mean, in 2005, you develop an application with completely different paradigms. It's such a complicated, and there is an anti-pattern, I discovered this the other day, called the frozen caveman. about this. It's like, oh, my paradigm, my patterns have worked for me forever, so they will work like this. And it doesn't happen. Particularly, it doesn't happen in tech. So what's the right attitude here? Well, I think that you need to learn the past, but take some distance. I imagine like a Bart, like someone that comes here and explains your story. And you just need to pay attention. Maybe you think, oh, well, the story was nice, but I didn't learn anything out of it. Or maybe say, well, I can apply that. So you should know the past and take your decisions. It's a bit like in Dune. I don't know. This is not very clear in the movie, but it's more clear in the novels. So in the novels, he's always able to see the future. But then only if you've seen the movie, you remember that scene. He drinks some kind of water and all that, and then at that moment he's able also to see the past. And just when he's able to see the past, he's able to see way, way, way farther into the future. I think that if you are able to do that, you will be able to help the Ruby community much more. And maybe you can continue doing presentations like this in 10 years. Thank you.
This was incredible. And I recently joined a company that has some of those problems. It's, I can relate. Do we have any questions? One over there and one over there. And another one over there. So shall we go left to right? I can share mine. That's okay.
Hello. I'm curious to know how long does it take to run the entire test suite? And just to confirm, are there 60 instances running in parallel of the?
Yes.
And also, what do you use to parallelize that?
That's interesting. I will have to check. It runs less than 20 minutes, and because we're running it all in parallel, of course. If not, it could be impossible. What do you remember what we use for running the test? Yeah, I can check. If you give me the contact, I can tell you. Hmm? Oh, I don't know.
We can check later after the
Yeah.
Sorry, I'll come back. Where was the over there? And you, right? I'll come. Okay.
Thank you. You mentioned using local gems to
Yes.
break some of your app complexity. I guess one question there is, did you have a dependency structure, or were all those gems that we saw in that screenshot required by the main app? And second, about Packwork, sounds like you're using some of that as well. Curious about your take on the different approaches.
Yeah, so that's a very good point. I mean, historically, like the idea of using private gems, like you take that, eventually didn't work. Because it is what you'd say, we didn't have like clear dependency maps. And right now, some of those gems are so strongly entangled with the monolith that you cannot use them anymore. Like we have some exceptions, and this is because we created pretty early a pretty successful application. And in this case, it's very clear that you cannot create PRs that are entangled too much the gem with the monolith. On Packwork, we're actually just experimenting at this point. I very strongly believe in it because I believe in monoliths, but you need to be well-organized monoliths. Like sometimes people say, oh, monoliths are like that, and it's not like that. It's just spaghetti monoliths, that the fact that you have a monolith doesn't mean that you can have a completely mess up map of dependencies.
And one more question here.
Yes, probably it's a silly question. You said that you test twice for every PR, right? Mm-hmm. I suppose that twice is one just as you file it to start the review, and one is a pre-submit check just before it get merged, or is something else?
No, it's something else. So it runs in parallel, they both runs, but it's not exactly the same PR in the way that one ran with Rails, the current version of Rails, and the other with Rails 7.1, for example. So, and the idea is that if once a test is green, we don't allow it to go back to red. Because a lot of times our Rails upgrade team says, well, I just fixed this, but now there is a new hole, so they wouldn't end if you wouldn't do this.
But when you don't change release, if you just have a PR with no release change?
What do you mean change release?
you're using the same Rails version, you're just changing something else without changing the Rails version.
No, like it's, so one run is with Rails 7 and the other is with Rails 7.1. But the thing is that to make Rails 7.1 completely green, it takes time. What we don't accept is tests that are fine, are green in Rails 7.1 to break them anymore.
So at any point in time, you always have a current version and the next
Yes.
version. Okay, sorry, I missed that. I thought it was like a one exception event, not at all events. Okay, got it. Sorry.
Yeah.
Last question.
I have a lot of questions, but let me ask one more about how you organize the code, because you're starting with Rails 1.0, right? So one question. It's in tests, let's say for the test, what folders do you have? How do you organize them? And how do you connect them with the code? Because when you want to change the code, you want to change the tests, right?
In the monolith, in the repo of the monolith, we only have unit test. And those correspond, it's like test, and they correspond to the file. Both for feature test, integration test, we actually have two completely different projects, one for the API and the other for the browser. And they run completely, we use Jenkins, and they are run completely, in a completely different way.
Okay, yeah. Yeah, sure. So still about the organizing code. So how do you organize, again about the Rails monolith, right?
Yes.
So how do you organize your code? Let's a bit about code design.
Yes.
Let's say, are you using namespaces? So I'm not talking about packwork, I know how it works,
Yeah.
but the one that is not there, right? Are you namespacing things? Are you
Yes.
putting everything in app models, or I don't know, how is organized?
We use quite a lot of namespacing. Like except even models are namespaced sometimes, but we use a lot of namespacing for anything related. Like for example, ticket. Again, I was saying that everything is a ticket. Ticket itself, like the model, maybe is probably 2,000 lines of code, but we have a lot of modules that are included into it, and of course they are namespaced under ticket.
And where is this ticket? In which folder do you have it?
It's app models ticket. So you have app models ticket RB, and then you will have a folder called app models ticket.
Yeah, that was
yes.
okay.
So yeah, ticket is a
yeah,
model.
I get it. Thank you.
Thank you very, very much. Enjoy the rest of the day.